Hello, everyone. Welcome to our presentation on the Trivial Compute project. We are Team Caffeine Coders, and we are excited to share our target increment presentation with you today. We have been fortunate to work under the guidance of our advisors, Dr. Sam Scalpo, Dr. Joe DiMasco, and Dr. Jeff Goronzik.
Introducing our team, Casey Rock, I'm the lead architect.
My name is CaffeineCodersFinal. I'm a programmer and a lead tester.
I'm Justin, and I'm the project manager and lead SQA engineer.
I'm Ting-Wei Wang, the presenter and programmer. Today, we'll be presenting our Trivial Compute project, structured to provide a thorough understanding of our work. From demonstration to analysis, we'll begin by reviewing the use case requirements before diving into a live demonstration, highlighting key areas such as the user management, game setup, and manage question and categories. Our focus will then shift to discussing our unit testing approach, which ensures the reliability of our code base. We'll also recap how our implementation aligns with the project requirements and showcase additional features that demonstrate our innovations. Finally, we'll reflect on the lessons learned throughout the development process, sharing insight into our success, challenge, and the valuable knowledge gained for future projects. Next up. So here is an overview of our project. So Trivial Compute is an interactive digital adaptation of the classic Trivial Pursuit game. Our aim has been to create an engaging, user-friendly platform that not only brings the joy of trivia into the digital age, but also serves as an effective educational tool. In our previous presentation, we introduced the core architecture and the minimal functionality of Trivial Compute as part of our minimal increment. We showcase foundational elements like the basic game board, player movement, and the core game logic. Today, we are excited to present our progress on the target increment, where we have expanded Trivial Compute to include full functionality. This includes key areas such as the user authentication, dynamic context management, enhanced user interface, secure deployment, and advanced game logic. In the following section, we'll delve into each of these enhancements, demonstrating their functionality and the value they bring to our project. We are eager to show you how our Trivial Compute has evolved and to discuss how these new features align with our overall project goals. Next up.
Starting off with user management and game setup, these are going to cover use cases 7 and 1. For use case 7, manage the accounts. This is going to be played by a teacher. And for this use case, the teacher is wishing to manage the accounts where they can add, modify, or delete accounts. The precondition for this is that the database has at least one existing teacher for them to authenticate into. The main flow goes as follows. Teachers select the option to manage the account. The system request for authentication. This is where the teacher then enters their username and password. Upon successful authentication, the system displays the account manager UI screen, where then the teacher then can select existing accounts to modify, add new accounts, and then to select to return back to the page. The post condition is that the accounts are modified, and then we head back to the previous page. This slide shows the non-functional and functional requirements for this. As you can see, this describes the workflow, how we manage this within our code. The user is interacting with the system. The first step is to authenticate in. Once they authenticate in, they can then modify accounts, add no accounts, and delete accounts.
During this demo, we'll be talking about how you can add and remove accounts to the game. By doing so, you can go to this Manage Account tab. So notice that the tab is grayed out, which indicates that we haven't been logged in yet. However, we can still click the account and we're prompted with username and password. If this is your first time and you have not created an account, you can click this new account button, which will then prompt you to provide a username and password for the new account that you like. I will be doing a test account, which will be test123@gmail.com. I'm going to provide a password. Once I press create new account, I can then come back into this page and log in using those new credentials. Upon successful logging, you'll notice that now these buttons go from gray to blue, which indicates that I have access to them because I'm logged in. Once we can do this, we can click on the Manage Account button, and you'll notice that the teachers who already established accounts as their Gmails will pop up here. From this tab, we have a couple options. We can create another account. So just say we want to add more teachers to this. I'll set up one. This account is now created and added into our database for tracking. If I'd like to delete the account, you can simply highlight over the account and just create it and press delete. This is now removed. And at this point, we're now able to manage the user accounts that come into this. The accounts are important because with the accounts, I can now update questions and categories in the game.
Thank you, Casey. Now we'll describe the process of playing the game. For use case 1, let's go through the steps involved when the player initiates a new game session. This process begins when the player indicates that they want to start a new game. The system responds by prompting the player to provide essential information such as the number of players, player names, and the categories that they want to include in the game. Once the player inputs all the required details, the system validates this information to make sure everything's correct. If it is valid, then the system will initialize the game by setting up the game board, positioning the players, and preparing category questions. Finally, the system will display the game board and signal that it's the first player's turn, starting the game. At this point, the new game session is active and players are ready to begin. However, if the input provided by the player is found to be invalid during the validation step, then the system will display an error message to inform the player. The system then guides the player back to the step where they can correct the information and proceed with setting up the game. For our other requirements, we will show game setup for 1 to 4 players. We'll highlight intuitive UI for the game setup. We'll note the loading times quick. We'll point out consistent visual design, mention adherence to trivial pursuit rules, show visual feedback during setup, and demonstrate how the game indicates the first player's turn.
Hello, this is Casey. For this video, we'll be demoing starting Trivial Compute game. This is going to be as the role as a student who's looking to play the game. So first, they press this button, which takes them to the game configuration. In here, we have the ability to remove players, add players. This allows us to now have to meet the requirement of 1 to 4 players. As you notice, once we get to 4 players, this button disappears. And similarly, it grays out, specifying the requirements for this. This also allows us to have the ability to modify the different categories based off of the selections that we have here. So these are pre-canned categories that come in. And you can assign colors to each category. Next, we have the game rules. This goes over the rules of the game, how the game's set up, the gameplay, how the game wins, then the special spaces. So the user can come in here to read all the rules that they'd like. And after that, once the game is configured, you have the player names added onto here. You're then able to press start game, where you then can be led to the game page for the start of the game.
Thank you, Casey. And now we'll describe the core game loop once the game is started. After the game was started in use case 1, then the proper game of Trivial Compute starts. This game includes our use cases number 2, 3, and 4, which I'll go over in detail now. I'll also continue covering requirements that will demonstrate we met as we go through the game, and then Calvin will provide a demonstration of the game and the requirements we met. Use case 2 covers how a player moves their game piece on the board during gameplay. First, when it's the player's turn, they roll the die to determine how many spaces they can move. Based on the player's current position, the system calculates the possible directions they can move and presents these options on the game board. The player then selects their preferred direction, and the system moves the player's token along the board until they've used up the spaces determined by their die roll. Once the player finishes their movement, the system updates their position on the board and, depending on where they land, transitions to the next phase, such as answering a question if they've landed on a non-center square. However, there are a few alternative paths that can occur during this process. If the player lands on a roll again space, the system will loop back to the beginning, allowing them to roll the die and move again. If the player lands on the center square, the system will transition to a different scenario where they must choose a category and answer a question. Finally, if the player encounters an intersection before using all their moves, the system will allow them to choose a new direction to use their remaining moves on. For our other requirements in this demonstration that we will show during the demo that are related to this use case, we will show smooth performance with multiple players. We'll point out score display locations. We'll demonstrate the active player indicator. We'll highlight intuitive movement interface. We will show feedback for dice roll and movement, and we'll note that the game is logging session data. Use case 3 covers answering a question on a square aside from the center square. If the player lands on a colored space, the system will display a trivia question. The player then gives their answer out loud. After answering, the player prompts the system to reveal the correct answer. Once the correct answer is shown, the player decides whether their answer was correct or not. If they believe they answered correctly, then the system will allow them to continue their turn and move their game piece again, following the same rules as before. The game state is then updated to reflect the outcome of that question. However, if the player admits that their answer was incorrect, then the system transitions to the next player's turn instead. If the space that the player lands on happens to be one of the 4 headquarters spaces, then after the player indicates whether they answered correctly or not, the system will either increase or not modify their score based on that outcome. The game will then continue as normal, allowing the player to proceed with their turn. For our other requirements, we will show an intuitive question interface. We'll demonstrate clear feedback for answers. We'll also note that all the questions are in the English language. We'll show video, image, and audio questions, and we'll demonstrate visual feedback for our answers. Now, in use case 4, we will go over what happens when a player lands on the center square and answers the trivia question there. When a player lands on the center square during their turn, the system will first prompt them to choose a category for their trivia question. After the player selects a category, the system presents a question from that category. The player answers the question aloud, and when they're ready, they'll prompt the system to reveal the correct answer. If the player believes their answer is correct, they'll confirm it, and the system will check if they've collected all the category pieces needed to win. If they haven't, then the system will allow the player to continue their turn and move the game piece again, and the game state will be updated accordingly. However, if the player answers incorrectly, then the system will transition to the next player's turn. In this case, the game state is also updated to reflect the incorrect answer. If the player has successfully collected all the necessary category pieces, then the game ending process starts. The system announces that the player has won the game, displays the final scores for all participants, and updates the player statistics and leaderboards. After this, the system prompts the players to return to the main menu, marking the end of the game session. Once the players confirm, they'll be taken back to the home screen with all relevant game data saved and the session marked as completed. And for our other requirements that we'll run into as we demonstrate this, we will show intuitive category selection interface, we'll demonstrate clear feedback for answers, highlight adherence to Trivial Pursuit rules for the center square, point out how the game tracks achievements, and demonstrate visual feedback for category selection and answers. All right, I'll hand it off to Calvin for the core game loop demonstration.
Awesome. Can we start this at 106, please?
Okay, so to actually initialize the game, once we fill out all the corresponding information here, we can press and start game. This takes us to the actual game board here. You can see the player tokens in the middle, the player scoreboards on the sides here, as well as the various different gameplay buttons here. So it's currently Larry's turn. Larry is the token in red and also player number 1. We'll prompt the user to roll the die. So let's go ahead and roll it. We've added a kind of a small animation here to kind of gamify this a little bit. So we roll a 2, and since we're in the center here, we're actually able to move in any of the 4 different directions. So let's go ahead and move left here. Okay, once we move left, it's going to take us to a green square, and that will prompt us with a history question. Okay, who was the first president of the United States? Well, that's George Washington, which means I've got this correct. And since I've gotten the question correct, it still is my turn. So we'll go ahead and roll the die again. Okay, we rolled a 4. So we move left, okay? And from here, where we meet an intersection, which would then prompt the user, do you want to move up or down? For the sake of this, we'll also move up again, which will land us on another history question. In which year did the Titanic sink? I'm not sure. 1912, correct. Okay. And since I've gotten the question correct again, it still is my turn. Let's go ahead and press roll the die. Okay, so now we've rolled on a red science question. This is one of the new question features that we've implemented here, which is a video-based question. Users can utilize the manage questions options and upload videos to create their own questions such as this. So which physics law does this video demonstrate? Press to play on the video. Okay, this is the conservation of momentum, correct. Okay, still my turn, we'll roll the die again. Okay, we'll roll a 3, so we'll move up. Okay, what is the name of this song? This is another new feature that we've implemented, which is audio-based questions. Likewise, of what I said before, users can create these questions, which will be then stored on our backend database. Since I've seen this before, this is the scheming weasel, so that's correct. Okay, we'll roll the die again. We rolled a 6 here, right? 1, 2, 3, 4, 5, 6. So we moved right twice here. We're going to land on the roll again. This is a special block that will prompt the user to re-roll the die without having to answer a question. So let's go gambling, roll again. We'll press roll again here. We rolled a 6, so let's keep moving around the board and for us to land on one of these HQ spots. What is the capital of Burkina Faso? Not too sure. Okay, still my turn. Okay, we'll move down. It's another roll again. Let's hope that we roll a 4 here. Okay, roll a 3. Okay, I'm just gonna skip this part as fast as I can to see if I can roll on the HQ spot. Bear with me. Okay. Okay, I guess luck is not on my side for this. Okay, we need a 1 to roll on 1. Okay, keep trying. Okay, we roll a 2. So once I move down, I'm gonna land on the HQ spot, which will then prompt me to answer a geography-based question. And if I get this right, I'm gonna be awarded with a point. So move down. Okay, what is the capital of Burkina Faso? I'm not gonna attempt that. Okay, so we've gotten this correct here. And see on Larry's scoreboard here, it is now populated with a yellow block, a yellow score point, okay? To speed this up a little bit, I've created a second web page here where I've traveled along the board and kind of answered a lot of the questions for player number 2 already, just to see what would happen at the final game screen. So we're gonna go ahead and move Larry, okay? And because this game will reference the previous game, the piece kind of moves a little bit awkwardly here. Okay, let's click incorrect here, which will then move me to the second player's turn. So here I am playing Curly, player 2. I am 1 block away from the center. Let's see if we can roll on that. Okay, nope. Okay, which year did Titanic sink? 1912. Okay, let's see if we can roll a 4. Okay. Let's see if we can roll a 3 to get to the center block. Okay. All right, I'm just gonna try to skip through this as fast as I can. Okay, we're on 5 HQ. Okay, we need a roll 4. Okay, we rolled a 1. Okay, so we're gonna move right here, which would land us on the center block. And the cool thing about the center piece here is that you're actually able to pick which question category you want to answer. I know a little bit more about art and literature, so let's click on that. Who won the Nobel Prize in Literature in 1970? I actually don't know this at all. However, the cool thing also about the center square here is that if once you've scored all 4 HQ points and you get the question right on the center square, you'll actually win the game. So let's go ahead and click correct here. All right, so now it says Curly is the winner. And one of the new features we've added to this final gameplay menu here is to showcase all the different statistics from the game, from the questions asked to the questions incorrect, as well as statistics for each player individually. Awesome, so now we'll click return home, bring this back to the home page to play again. Hello, everyone.
Okay, this takes us to use case 5 and 6, where we'll be managing questions and categories. This is essential for the game because this teacher allows us to create questions and categories in the gameplay. So looking at use case 5, manage questions. This is where a teacher wants to add, modify, or delete questions. The precondition is that the database has at least one trivia question. The main flow goes where the teacher selects the option to manage the question. Some of the new things that we added, which are highlighted in green, or authentication, and with the ability to have username and password. Once authentication is completed, you get moved over to the Manage System UI Question Manager screen, where then you can select to modify or preview some of the questions. Then you're moved to the System Display question, where you can add and modify the questions. Some of the things we've also added is we have the ability to change text, video, and image questions based on their categories. So the video, image, and audio are the new ones that we've added as displayed in the previous one. Once these questions are correct, you'll be written to the new question to our database so that it can be logged inside the game. Once you do that, the teacher can select exit preview and then return to the home screen. Some of the alternate flows are that if the teacher adds new questions at step 5, the system displays the question UI to add or modify. They can then prompt what type of feature they want, so whether it's a text, video, audio category. Then the system can then write the new feature to the database, where then the teacher then can edit the screen. Another post condition that we have here is that when a new question is added, that continues the alternate flow for 1. The second alternate flow is that the teacher indicates to delete the second question at step 6. This is where they highlight over the question and deletes it. Looking at some of the other requirements, we have show intuitive question management interface. We want to mention well-documented code for maintainability, highlight use of team's current skill sets, point out the use of open source tooling, mention stage delivery methods, note proper attributes of any third-party libraries, show user-friendly error messaging and management, and then demonstrate the visual feedback for users. The second use case, manage categories. In here, a teacher will go through the page to add, modify, or delete existing categories. The precondition is that the database has at least one existing category. The way the flow works is the teacher selects the option to manage categories. Like we have again, authentication occurs, bringing us to the category manager system UI. The teacher can then select existing categories to modify, change the features in the account, which will change the name in our database, write the new features accordingly to the database, and then select options to return to the screen. Alternate flows are the teacher indicates they want to add a new category at step 5. This is where they populate the feature of the category in one of the input boxes. Once this is completed, you can press the button to add new category, which writes it to the database. Second alternate flow is delete a category. So you can select the category you like, press the button to delete it, and then the category gets deleted from the database. Some of the other requirements here is that we want to show intuitive category management interface, mention well-documented code for maintainability, highlight use of team's current skills, point out use of open source tools, mention the stage delivery, show user-friendly error messaging, and then demonstrate the visual feedback.
For this demo, we'll go over the manage questions and manage category portion of Trivial Compute. Notice that the buttons are blue, indicating that we've already authenticated in as a teacher. This allows us to go into these buttons without having to authenticate again. So clicking on the manage questions, what you'll see is that this page queries the database and returns all the questions that we have. Each question has a category, a format, and an actual question. Obviously, during the game, there's more information that gets displayed, but for the manage questions page, this is what we have here. Inside manage question, some of the new things that we've added for the target increment. Underneath the new question creation page, we can start to add more type of questions. This includes video, audio, and images. So if we start to create a new question, we can continue from the minimum increment and select the difficulty. The new thing that we've enabled is more question types. So let's add a video. Provide the answer to the video. select the file that we want to upload. So we'll upload this. And after we've added the video, we'll get prompted the question is created. So if we come into exit the preview, you'll notice that our question has now been added into the manage question page for us to then keep track of. This will be then displayed throughout the gameplay as one of the questions. We can also upload images and audio type questions. It's handled similarly to video because these are all files. We simply upload the files to the database and then keep the metadata tagged into a separate database. If we want to delete the question, we simply highlight over the question that we want and we'll delete the one we just created. Scroll down and hit this delete selected question. As you can see, once the question is deleted, this list automatically refreshes, and now we don't have the question in here. Returning back to the main page, notice that we're still logged in, so we can authenticate into the next pages. We want to go to the Manage Categories button. Similar to the minimum increment, nothing has really changed here. We still have the ability to add new categories and remove them. We also can rename categories. So let's do a test here. Let's create a new category called Test. Click the Add button. This is now added into our database and used as one of the categories for the game. And simply renaming it to Test 1. You see this updates automatically. And then if we like to delete the category name, we can hover over it again and press Delete Category. This concludes the Manage Questions and Manage Category portion of the demo.
Thanks, Casey. For our unit test, we utilize Jest, which is a really popular JavaScript testing framework developed by Facebook. We use Jest to perform unit tests on essential gameplay functions such as game initializations, question retrieval from the database, as well as player movement and scoreboard updating. We focused on boundary testing after identifying equivalence cases for functions. We mostly considered edge cases such as categories with the minimum number of questions and scenarios with 1 to 4 players with unique long character names. Currently, we have achieved 57% statement coverage. Our test cases cover unit testing for all client-facing functions in the game session class, as well as integration testing among game logic-related classes. We prioritize testing the game session class because it is the most complex, serving as a facade class. Looking ahead, our future steps include increasing statement coverage and implementing basis path testing to ensure more thorough coverage of our code.
Thanks, Kelvin. So here, in addition to the core use case functionality, we thoroughly fulfill the project requirements for trivial compute across 3 main areas: the non-functional requirements, design and implementation constraints, and the function requirements not tied to specific use case. The game supports 1 to 4 player with smooth performance, an intuitive interface, and consistent visual design. They load quickly, adhere to Trivial Pursuit rules, and utilize our specified frameworks and team scale effectively. Additionally, we have implemented essential features like session logging and user-friendly error message, ensuring the game is robust, accessible, and fully aligned with project specification. This comprehensive fulfillment reflects our commitment to delivering a high-quality educational game. Next up. Our team went beyond the project requirements by introducing several advanced features that significantly enhance trivial compute functionality and user experience. We implement a comprehensive user management system enabling seamless account creation, deletion, and modification, ensuring personalized gameplay and efficient data management. Through rigorous testing with J-tests, including unit and integration tests with detailed coverage reports, we ensure the application reliability and stability. We also adopted an industrial-centered architecture featuring a RESTful API for efficient client-server communication and a cloud-based database to improve scalability and performance. Additionally, we developed an intuitive in-app interface for managing questions and categories, allowing authorized users to easily update content without back-end access. This enhancement not only elevates Trivial Compute's current capability, but also establish a scalable, maintainable foundation for future expansion, showcasing our commitment to delivering a professional-grade, real-world-ready product.
And the last two slides that we will talk about are the lessons learned that we had during this type of project. We felt that it was useful to have this attached to our presentation so that we can talk about it as a team. So some of the things that worked really well for us, starting off with team communication, because all of us were asynchronously working on this and sometimes even in different time zones, we had an instant message over Discord, which worked really, really well for communicating rapidly. Posting different codes to Discord, having channels where we could meet was really effective. We also used an ad hoc meeting strategy through Discord, where we would hop into one of the meeting voice channel rooms and discuss the product that we were developing. We used agile development principles, where we were following sprint cycles that helped us develop the increment minimum and target increments. This was really helpful for us because we were able to use some of the agile methodologies. We were able to version control of our code using GitHub. This is really helpful for us to pursue forward. Some of the things that didn't really work too well, authentication was implemented. However, some of the ways that we had it inside of the server and how it interacted with the client took too long for us to fully increment and test out authentication. We did have the fundamental authentication, but there's still more that we could have done. And lastly, it took too much time for us to get to the dream increment, which would have been using AI to help act as non-playable characters. Some advice that we would tell to the people taking this course next to start early. We found that as we were developing it, we had to cram a lot of code in to meet some of the increments based off of how difficult this was and all the features that we had. We also want to prioritize core features. As we specified, there was a lot of other components that we added. However, the core features of the gameplay was something that we want to have we should have prioritized. And then balanced learning with doing to maintain progress. So there was a lot of things that we had to learn as we were developing this, and some of the tools and open source tools, especially Firebase, was very new for some of the team members. So we had to balance learning with actually doing it. And then one of the things that we can use in our real projects. Starting off, we gained a lot of experience with Google Firebase. This is a cloud service hosted by Google, and we use the free tier, which allowed us to move really quickly without having to pay for any of the cloud resources. We also used a RESTful API as our server. This is really useful because this is how we can have modern client server architectures. Some of the other techniques that we learned throughout this are object-oriented design. And then a useful thing that we thought that was really cool that we wanted to include was the use of generative AI. We used this throughout the project extensively, and it was really good for debugging code. One of the things that we found is as we were running through errors, we could paste the errors into ChatGPT, and it would at least lead us down the right path for us to increment. This concludes our presentation for Caffeine Coders. Thank you for your time as we close out this presentation.